In August, the Council Ranger District ID team held a one-day workshop on a road inventory and modeling system called GRAIP. And it is a tool that has been used to help identify sedimentation problems and delivery of sediment to streams, and to prioritize rehabilitation investments in roads, including surfacing and as well as decommissioning of roads. And previously I posted some photos from the afternoon field trip that we had. They're sort of in the typical Atlas two-dimensional format, and I thought just to give a little bit better background on potential application for monitoring on both the Mill Creek and the Lost Creek, Boulder Creek projects, I would do it in this video format. So first, just an overview. The project area for Mill Creek Council Mountain is approximately here. You can see Donnelly over on the right and Council over on the left of the image. In the draft EIS for the Mill Creek Council Mountain project, there was a great deal of discussion about the potential benefit of road restoration actions and investments in the project area. In particular, of the Weezer River and Dewey Creek, which are the two sub-watersheds that were identified by Fish and Wildlife Service as bull trout critical habitat. And these were the high priority areas for restoration treatments that created the need for the ID team to design a fifth alternative, which eventually at the end of the EIS became the preferred action, and that was subsequently modified. So the symbols on the map, these blue symbols are actually photo points from the 2010 flood and extreme weather event. And then the individual pictures that you see, these small thumbprint pictures, are point photos from the field tour in the afternoon. But again, this is just a portion of the Mill Creek Council Mountain area, but it is an area that was very much of interest in the review of the draft EIS. So what does this have to do with a road inventory and modeling, sediment modeling exercise? Well, the ID team for Council Ranger District is considering spending monitoring funds on this to help identify those areas where your landscape would receive the highest benefit from the investment of restoration dollars. And the field trip in the afternoon was to help get an understanding of the road inventory protocol and the method, and then the potential outputs from application of that inventory and modeling effort. Now the world's going to turn upside down here for a minute, and we will start with the tour stop. But first, just a couple of photos from the 2010 flood event. I think just to refresh everybody's memory, this was a big storm that had a significant impact on the road network system within the project area and other places on the forest. Here is an example of a tributary that changed course just above the culvert, and as the note describes here, it deposited debris across the road. And a second example, this is above Joker Creek, but this is a cut slope failure along the East Fork of the Weezer River Road. Now, these are pretty extreme examples in a flood event of sedimentation, and although the tools in GRAIP do look for risk from mass wasting, either landslide points or from gullies, there is also a base level of sedimentation each year that is delivered to streams. The purpose of this isn't just to address these extreme conditions, but to improve the existing sediment contribution from roads through restoration actions and prioritizing those actions to get the most benefit from the dollars invested. The tour started down in this area of the watershed, and this is at the juncture of the East Fork and Joker Creek, as well as Dewey Creek. And at this first stop, parked alongside the road, we saw was an example of the road inventory protocol applied to identify channels that deliver water and sediment to what, in terms of the model, is called sediment delivery points. When, in this case, along the road, there is a channel that you can pick up on the photo that goes along the side of the road. And in this methodology, when they describe a delivery point and show delivery points on a map, this is an example. So that channel along the side of the road terminates here and delivers water and sediment to the base of this culvert. And this is the intersection of Joker Creek with the East Fork of the Weiser River. Now, the modeling approach and the inventory is really high detailed. So the other point of interest at this tour stop was on the right side of the road. There is another delivery path for water and sediment that goes to a different point on the stream and is actually closer to Dewey Creek. That's a couple of examples from tour stop 1. Going further up the watershed, this was a field tour stop where we looked at an unauthorized road and dispersed camping. Now, this is a little bit more difficult to see, but in the spring, the spring melt-off and runoff is sufficient to deliver water across the photo in this direction and eventually delivers it to a stream. In tour stop 3, Melanie Vining is standing in a spot where there was a culvert plugged in the spring of this year, of 2012. And in the inventory process, the field crew would rate this as a high risk because the culvert pipe, is narrower than the channel. And then because of that, the water diverts to the road instead of going through the culvert and delivering as it was designed to do. And this photo shows the pipe size that is right in front of where Melanie was standing. This picture is the opposite direction, and it's a little harder to tell the dimensions on this, but the natural channel here is larger than the size of the culvert, the size of the pipe delivering the water, and that was a contributing factor to the overflow. Stop 4 is an example of another item of interest for the road inventory, and that is to identify candidates to improve fish passage, replacing, in this case, the existing pipe with an oversized pipe. And this photo is taken from back up on the road and is a view downslope of the fish passage candidate site. And at that same location, here is another example of a delivery point. Both you can plainly see the channel that was created over time along the side of the road. And tour stop number 5 is an example from the 2010 storm. It caused water to overflow going from the right towards the road, overflowed the pipe, and the water crossed the road, creating another rehabilitation candidate to reduce the sedimentation. This is the same location, and Melanie and Tom Black are standing on a pile of rock and soil that was delivered as a result of that overflow. And to end, I'm just going to give you an example from the modeling output. And this is a map that that documents the road sediment production and delivery. The road segments are color-coded based on their likely sediment production in terms of weight per year. And the red circles in this map are the delivery points for this example. And the size of the circle, the red circles, are sized according to the estimated delivery of sediment at that point and subsequently to the stream. I should also mention that this is an example from another project. The analysis has not been applied to the East Fork of the Weiser River watershed yet.